Are you the curious type? Welcome to the channel full with curiosity answers. Please subscribe as we carry you in this interesting journey of discovery. Do you mind to know what might happen if a gun is fired in space? Here are the answers for you. Very few experiments done in space have been intended to satisfy scientific curiosity about a hypothetical and inconsequential matter, such as what would happen if you fired a gun in space. You may remember from elementary school science class that a fire needs three things: heat, fuel, and air in order to work. A gun works by harvesting the power of fire in a manner of sparking by creating an explosion that propels the bullet from the chamber. However, as there's no air in space, a key part of the equation is missing. 1. The bullet would fly off into space indefinitely. That's not a problem, however, as modern-day ammunition contains its own oxidizer, a chemical that allows combustion to take place in the absence of air. Since everything you need is right there in the bullet, the gun and bullet will work in space just as well as they would on the ground. There would be some minor differences, of course. Unless you shot it from inside a spacecraft, which would be a terrible idea, you wouldn't hear the explosion due to the lack of air in space to carry the sound waves. And instead of a wispy vapor trail like you see in the movies, the smoke would just expand in a sphere from the tip of the barrel. On the ground, gravity and friction will mean that the bullet can and will only fly so far. In space, gravity and friction are still factors, but their effects are completely different, and this would be particularly evident if you fired a bullet up there. Harvard astronomer Matija Cuk explained that once the bullet is fired, it's likely going to travel in space until the heat death of the universe. The bullet will never stop because the universe is expanding faster than the bullet can catch up with any serious amount of mass to slow it down, Cuk noted. 2. The shooter will also be shot into space. Of course, this assumes that the bullet won't be captured by the gravity of a star or planet and eventually brought back down. But considering that objects with actual mass, such as stars and planets, take up so little of the universe compared to the vast expanse of space, that the likelihood of that happening is extremely small. If you've ever fired a gun in real life, you're almost certainly aware that the process produces a kick that you have to expect and likely brace yourself for, lest it disrupt your balance. Holding the gun the wrong way can produce a kick that could injure the shooter, to say nothing of interfering with the gun's aim and endangering bystanders. The kick is the result of one of the foundational rules of physics, Newton's third law, which says that for every action, there is an equal and opposite reaction. In space, with the absence of gravity and friction, that means that the bullet will be sent off into space in one direction, the shooter in the other direction. As this YouTube video explains, just how fast the bullet and shooter will be sent off in their respective directions depends on the velocity and weight of shooter and bullet. The video notes that firing an AK-47 will send the shooter backwards at 0.068 miles per hour, while firing a small handgun with a slower moving but heavier bullet will send the shooter in the opposite direction at about twice that speed. 3. You could shoot yourself in your own back. Imagine being an astronaut orbiting above the Earth on a spacewalk, for example, far enough away from your spacecraft that you could fire your gun without endangering your crew. You, your craft, and everything else at that altitude are all orbiting the Earth. And, as Live Science explains, if you fired your gun at exactly the right angle, the bullet would also go into orbit around the Earth. You may be seeing why this would be a problem, but if not, here's what could happen. Since orbits are circular, the bullet will eventually make a circle around the Earth and come back to where it started. And since you are now positioned between the bullet and the starting point to which it is returning, you will have effectively shot yourself in your own back, says Brown University astronomer Peter Schultz. The aim has to be perfect, he added. If this all sounds a bit theoretical rather than practical, keep in mind that, as Schultz explained, scientists have actually considered self-hits in space in order to investigate impacts with tiny asteroids, space junk, and so forth, but thought better of it. To stay informed, please subscribe to our channel. Thanks for